In number 1, we have a function on interval 1, 4, and in part A, we want to find the absolute maximum and the absolute minimum on interval 1, 4. So we're going to start by taking the derivative and finding critical values. Remember, critical values are where the derivative is 0 or where the derivative doesn't exist but the function is continuous. In this case, the derivative will exist everywhere, and the critical values will just be where the derivative is equal to 0. So let's take the derivative, just use the power rule, and we have minus 2t plus 4, and we want to set this equal to 0 and solve. So we have 2t equal 4 and t equal 2. So this is our one critical value. Notice f prime of t exists everywhere, so we don't have any critical values of the other type. Now, to find absolute max and absolute min, we test the critical value and the two endpoints 1 and 4. We make a little table. So the values that we're going to test are the critical value t equal 2, and the endpoints t equal 1, and t equal 4. And what I mean by test is we're just going to substitute into the original function into f of t and see which is the biggest and which is the smallest. Again, the absolute min of a function on a closed interval occur at either critical values or endpoints, assuming that the function is continuous. All right, so let's figure out start with f of 2. And again, we're substituting right into minus t squared plus 4t, so that would be minus 2 squared minus 4 plus 4 times 2 plus 8, and we have 4. All right, now let's do f of 1. Okay, substituting into here, we have minus 1 plus 4, and that's 3. Okay, that's a 4 over there. Okay, let's now do f of 4. That would be minus 16 plus 16. And that's 0. So the largest is 4, so we have our max occurs at t equal 2. And our min is 0, so we have the minimum occurs at t equal 4. So the point at which the absolute max occurs, that would be 2, 4, xy, or actually t f of t, and the min, that would be t equal 4, and the function value is 0. So those are the points. All right, now in part B, we want to find the average rate of change. So let's remember the formula for that, average rate of change. We have, okay, average rate of change, and we're talking about on an interval, let's say AB, that would be f of B minus f of A over B minus A. So in our case, we have f of B is the interval is 1, 4. So we have f of 4 minus f of 1 over 4 minus 1. F of 4 is 0. F of 1 is 3. And 4 minus 1 is 3, so we have minus 3 over 3. Or an average rate of change of minus 1. In the second example, we have this function on interval 0, 3, and we want to find the c of the mean value theorem. So let's just recall the mean value theorem. If we have a function that is differentiable on AB, then for C in AB, that is, there exists, let me write there exists, C in AB, where f prime of C, the derivative, is equal to the slope of the secant line from A to B. That would be the slope formula f of B minus f of A over B minus A. So in our case, the slope is equal to f of 3 minus f of 0 over 3 minus 0. That's our interval is 0, 3. Let's look at f of 3. Substitute in 3, and we have, we'll do it right here in parentheses, we have 9 minus 4 times 3, 9 minus 12, that's f of 3. Now let's look at f of 0, and we have 0, 0 minus 0, over 3 minus 0. So for the slope, we have minus 3 over 3, or a slope of minus 1. So we want to find C such that f prime of C is equal to minus 1, and C in the interval 0, 3. Okay, so let's take our derivative, f prime of x, and we're going to set it equal to minus 1 and solve. F prime of x, using the power rule, that's 2x minus 4. Set it equal to minus 1, and we have, adding 4 to both sides, 2x is equal to 3, or x is equal to 2/3. Now 2/3 is in the interval 0, 3. All right, 2/3 is bigger than 0 and less than 3. So this is our C from the mean value theorem.